Okay, I'm just going to run through this question here. So they've kind of split it up in different parts for you. So we're just going to work through what they've told us to calculate. So the first thing they're asking us to do is calculate the mass of ethanol burnt. So essentially what we need to do is work out the difference in mass of the spirit lamp and ethanol. Okay, so we're going to do the initial mass of spirit lamp plus ethanol. So this number here, take away the final mass of spirit lamp plus ethanol. Okay, so if I do that, if I do 78.45 minus 77.56, I get an answer of 0.89 grams. Okay, it's then asking you to work out the moles of ethanol burned. So the first thing I'm just going to go over is what the formula for ethanol is. So ethanol is C2H6O. Okay, so based on that, the MR of this is 46. So if we're working out the moles, we're going to do mass divided by the MR. So we're going to do 0.89 grams divided by 46, and you should get a rather long number in your calculator. I'm just going to round it to 0.1935 moles. Okay. They're then asking you to calculate the temperature rise. So over here, we've got our final temperature of 88. We're going to take away the initial temperature, which is 23. So 88 minus 23, you should get 65 degrees Celsius. So as I said, don't worry about converting it to Kelvin because we're working out the difference. If we convert it to Kelvin first and then work out the difference, you should still get a value of 65. So do not convert it to Kelvin here, you're just wasting your time. Okay, so the temperature rise here is 65. It's then asking us to calculate the energy gained by the water. So energy gained is Q, and as we know, the equation for Q is M times C times delta T. So over here, M is the mass of surroundings. So in this case, the mass of the surroundings, so the surroundings is water. The mass of water is 250 minus 150. So that's just going to be 100 grams. Our C, they have told us, is 4.18, which it usually always is. And our delta T, which we worked out, is what was it, 65. Okay, so to work out Q, I'm going to do 100 times 4.18 times 65, and I get a value of Q as 27,170, and this is in joules. Okay, but they're asking us to calculate it in kilojoules, so to convert this number into kilojoules, I'm just going to divide it by 1,000. And that then gives me 27.17 kilojoules. Okay. Then it's asking us to calculate the enthalpy change of combustion. So if you remember, to calculate the enthalpy change of anything, it's the Q, so the energy in kilojoules, divided by the moles of the reactant. So in this case, the reactant is our ethanol. So we're just going to do our Q in kilojoules, which is 27.17, divided by the moles of the fuel in this case. So that was ethanol, which we've already worked out, which is this number here. So 27.17 divided by 0.01935. And that should give us our value. I'm just going to round it to 1,404 kilojoules per mole. But I still haven't got all the marks. I've dropped one mark so far. Okay. The reason being is I haven't decided the sign of my enthalpy change. Okay. Because the temperature increased, it was a hot reaction. Okay, that means it is an exothermic reaction, and as we know, exothermic reactions, the enthalpy change always has a negative sign. Okay, and to be honest, combustion reactions are always going to be negative because they're always going to be exothermic, so that is worth bearing in mind. And that there is our final answer. It also says to suggest 3 reasons why the enthalpy change of combustion values calculated here, calculated via this apparatus is so inaccurate compared to the data book values. So there are 4 reasons that we've discussed. You can write down any 3 of those 4. So the first one we said is, the major one, is heat loss to the surroundings. Okay, so that's one. Another one could be that we could have incomplete combustion. Because we could be forming carbon monoxide and water, not carbon dioxide and water. So we could have incomplete combustion. A third one could be evaporation of the ethanol. Because ethanol is quite volatile, it does evaporate fairly quickly. Okay. And the last one, it could have been done under non-standard conditions. I know it's only asking for 3. I'm just going to list all of them. Okay.